All right, so in this class I would like to continue talking about, let's say, ways to program in particular debugging programs. So in this lecture on debugging, what I would like to show you is, let's say, in the old way of doing things, what you would probably do is you would put printf statements or any kind of statement that prints some output into your code. You would recompile it, you would run it, it would print, let's say, the values of variables that you want to inspect, and if they are not quite what you expect them to be, you would repeat this whole process. So I see this with a lot of, let's say, younger programmers, people who don't have, let's say, the experience in using tools, that basically they debug their program using printf. And that's a valid approach to do it, and there are certainly times when I do that too. But it's an approach that takes a lot more time than is necessary. And the primary reason why it takes time is, well, first you have to write the printf, of course, and you have to identify what it actually is that you want to print. But then also to compile large programs just takes a lot of time. I mean, it takes 20 seconds to compile one of these deal.II tutorial programs, and maybe it takes another 30 seconds or a minute to actually run it before you get to that point. So this cycle of writing code, compiling it, running it, and going back to editing it just takes a lot of time. So as opposed to this, the alternative is to use a debugger. What I would like to show you is how in a debugger you can step into and out of functions, how you set breakpoints, how you evaluate conditions, for example, how you inspect variables, and so on and so forth. So I think one of the things that we have all learned is that once you know how to use a debugger, you will never forget about it. You will always appreciate the ease of getting at the information that you really need. So what I'll just do is I'll give you a very practical example of this. Let me go into my Mass 676 deal.II example step 6 directory. And I'm going to show you how to use the debugger that is built into Eclipse. So it's going to take a little while before it's loaded. What I've already done is that I've set up a project for step 6. So you remember in the classes on step 6, I showed you how to set up a project for this. So here's my step 6 example program. What I've also done is I've set up a makefile target, and so let me compile this. Oh, I can't do this. I first need to call cmake, of course. Cmake minus d deal.II dir equals the place where I installed deal.II. So that is my home directory, then bin deal.II 8.0 pre, and then the place where the sources for the current project are located, that's the current directory. So let me call this. Now I can call make all. So that's going to compile my program. And then what I need to do is I need to set up the executable for this. So you see at the bottom here how it compiled it. Then let me select step 6, project actually run. I need to edit the run configurations. I have already added step 6 here. Let me show you how this works in general. Let me delete this for a second. So I go onto C++ applications. I need to add a new launch configuration because I've highlighted the step 6 project here. It has already set this up. So the application is called step 6. And then I say run. And so what it does here, you can see how it actually executes it. So step 6 runs for 8 iterations, starting at iteration 0, I believe. Yes, starting at iteration 0. And from now on, I can run it by clicking on run step 6 here. So this is the way to do it. What I would like to show you is how you debug this. And so to this end, let me introduce a bug into this program. So if I go into my editor window here, let's say, let me hit Ctrl-O, I get an outline. And what I want to do is I want to go to the function setup system. So this is the declaration, here is the actual definition. Actually, let me, so that it's easier to see, let me strip all of these comments here. So in my shell window, I can say make strip comments. And so all of the comments have disappeared. Setup system. So let us, for example, assume that in this setup system function, what we do here is we, on every mesh, we distribute the DUFs, and then we initialize the solution and right-hand side vectors to their proper sizes. So let's say I had forgotten about initializing the right-hand side vector. Of course, I will eventually get an error because deal.II will check that I'm now accessing something that, or I'm accessing elements of this vector that don't have quite the right size. So I've saved this. Let me compile this. Let me also show you the output again. So it compiles. And let me run this. And I get an error message here. So the error message, you remember, you've seen this before, that it gives me a backtrace here. It started at main called run called assemble system called distribute local to global to global called initial, distribute local to global function, and so on and so forth. The error message that it actually gives me here is, let me make this a little bit bigger. The error message looks like this. It says an error occurred in line 2313 of this and this file in this function, constraint matrix distribute local to global. And what it says down here is that the dimension 89 is not equal to 0. So it's trying to match the dimensions of a vector and the matrix, and it finds that they don't match. And then it aborted the program. So in order to find out what's happening here, let me call the debugger. Okay, so I'm going to run the entire program in the debugger, and I think I've showed this to you before in one of the previous lectures as well, that is going to open when the debugger actually is started. It is going to open the debug perspective, and you can see this over here to the right. So this is where I got now. So the debugger, by default, just stops in the first line of actual code in main. And from there, we can find our way. So up here in the left, you see what is called a backtrace. It says that right now, we're executing thread number 1, and we're in the main function. And then there's all of these symbols up here that you will use quite frequently, or you will use the key commands for this. So in particular, step over means, well, in this function, in this line here, for example, we call this function depth console. And if you hover over it, you get to see the details of this deal log variable. So I don't want to go into this one. I just want to execute this line and go on to the next line. So what I'm going to do is I'm going to call step over, F6. Let's say here, this is the constructor of the step 6 class. Maybe this is where the problem actually happens. So what I should do is I should go into, step into. Okay, so I click on this one here. It turns out that that is actually not a very interesting function. Nothing can happen here. Nothing actually does happen here. So I have these initialization things. I should just step over this. And then one of the things, when I realize that this is not the problem, or this is not the function that I care of, what I should just do is let us run this function to completion and jump back out one level. So whatever code is left in this function I don't care about, I'm going to say step return, and it's getting me back right here to this place in main. Let me ignore these errors here. So then the problem must be in this run function. So maybe I should go in there. So let me step into this one here. So I end up in this place here, and again I could say step into or step over until I finally get to the place where I want to be. In this case, I don't really know where that problem happens. So what I'm going to do is, instead of single stepping myself through the program, I'm just going to use this button here that says resume. So essentially it's just going to continue the program until either I halt it or it aborts. So in this case, it will abort with this error message here. And so if I go back to the window where I had my backtrace, this is now where this happened here. So in this debugger window here, I get to see that the problem happened in a function that's called raise, that's in an operating system function, which was called from a board, which was called from a whole bunch of functions in deal.II. Ultimately, I started at main. So what I can do is I can look at the places where this happened. So let me continue to ignore this here. So I started in main. It happened in this line, which called this run function, which called right here, which called assemble, which called distribute local to global. And so what I should look at here already is that this is the function where I pass these different arguments: cell matrix, cell right-hand side, system matrix, and system right-hand side. And so I can already hover over these variables and get some sort of insight. But ultimately, what you will have to find out then is, well, so what's happening here? So if I look at distribute local to global, essentially it just forwards this. And eventually you will come out to a place where you will find an assert dimension where it verifies that the size of this matrix here equals the size of this vector. And that's the place where, so global vector is a vector that has size 0. I can look at this by going here. So I see that the vector size is 0, whereas for this global matrix here, I will find that if I look at this closely enough, it's a little bit hidden. It is here in this calls array. There will be a place where it says something about the size. And it's actually, you need to know these sort of things if you want to find out about this. But you get the idea that I can look at variables. So here it says the number of rows and the number of columns is 89. So I just have to look at sub-variables of these variables. The point is that when you know where the problem happens and when you see the error message, typically you will find the place. So you already know now that the size of a matrix and the size of the vector don't match. You know that the vector size is 0. So if you go back here, you will remember that, okay, so these are the matrix and the right-hand side that I pass. If the size of this system right-hand side vector here is 0, that is certainly the problem, and I have already identified then that I need to resize this one. So that will help me really quickly to fix my bug. Namely, I go back into the editor, I find myself the place where I reinitialize these variables. This was right here, and I'm going to fix this. So I fixed my problem, and that solves that. Let me show you different ways of interacting with the debugger. So in this program, if you look at the output, it produces files grid0 through grid7.eps. And if I hit Ctrl-O, I get the outline again. This happens in a function output results. And output results creates these file names in the following way. So it has a string grid dash, and then it adds to this string something of this kind here. So it gives, I add to the character 0 the number of the cycle. And that looks a little bit odd. If you're maybe not quite sure what you're doing, maybe you should have, or you would have thought that I should write it like this. So I should just take the number of the cycle, convert it to a character, and add it to a string. It seems like a reasonable thing to do, right? So certainly if cycle is 3, the corresponding character would be the character 3, right? That is not true. So if I execute this one here, then what you will find is that the output files don't quite look the way you thought they would. So it's compiling here now. And while it is compiling, let me delete all of these output files. And so if I execute this now, what you will find is that these output files, they have sort of odd names, grid dash and grid dash question mark, and there's multiple ones that look as if they have the same file name. That's certainly not what we intended. So let us try to debug what is happening here. And in order to do this, what I'm going to do is I'm going to, so I know it must be happening here. If you click into the left margin of this window with the right mouse key, it's going to allow you to toggle a breakpoint. So a breakpoint is something where the debugger will stop when it hits that line. So I'm going to toggle this breakpoint here, and then I'm going to start the debugger. That will take me back into the debug perspective. Let's see what happens. Okay, so it is still running. Okay, so let me abort this program here, and let me just start from scratch. So it was still running the previous incarnation of this program. So I started again. It takes a couple seconds for the debugger to start up. I end up again in main. Instead of single stepping through it, I'm just going to say continue. And what it's going to do is going to stop at the place where I had my breakpoint. Okay, so you can see over here in this window where I have the breakpoints, you can see that there is a breakpoint in line 290. What I would like to do is in this place, I would like to show me all of the local variables. So one of the things that you can see here, for example, is that the cycle variable is 0. Okay, so that's the function argument. And if I look at this file name, at this line right now, it is just garbage because it hasn't been initialized yet. So let me single step over this. Okay, so I'm going to step over this. And now you see that the file name is already grid dash. Okay. Now, what's going to happen if I add the cycle to it? So I'm going to single step over it one more time. And now I find myself in this line here. And you have seen that the file name actually hasn't changed, or at least it appears as if it hasn't changed. And if I add this .eps, so I'm stepping one more time, what it actually shows me is that the file name is now grid not -0, but \0. So that's the character that has the integral value 0. That is not the character that prints as 0 on the screen. As a matter of fact, the 0 character in C is typically used as the end-of-line character. And that's why we get this problem. So here apparently is the problem. Maybe we haven't quite figured out what, let's say, what the system is, right? We see that something is wrong, but we haven't quite understood the pattern behind it. So maybe what I should do is I should just continue this, resume, and just look at the next time I get there. Okay, so let me go back to the debug window here. So I'm again in output results, and this time cycle equals 1. So I keep single stepping. Now you see that the file name is grid \001. And so we start to see a pattern here. Now, I think from this you can already, let's say, recognize what we need to do. But I want to show you a few more tricks that we could do with this. So let's say we have realized that, well, the first couple times around, that sometimes happens. You call a function with particular input values, and they are always all right. But sometimes with particular other arguments, you do get the error. So one of the things that I could do is I could right-click on this one here, and I could add a condition to this. So let's say breakpoint properties. And so I can add a condition. So let me say, for example, that I only want to stop in this place if cycle is greater than 4. Cycle is the function argument. Okay, so if I go to breakpoints, I'm going to now see that, so the breakpoint is in line 290. The condition is that cycle is greater than 4. And so if I debug it now, what it's going to do is it's going to start my program again, hopefully. And it's going to stop in main. And then when I continue, it's only going to stop this in line 290 when the condition is actually satisfied. So before, it stopped every time I got into this function. If I say resume now, you see it runs through the first 5 iterations already. And if I look at the variables now that it stopped here, you see that cycle is greater than 4, namely it is 5. Okay, so you can make sure that breakpoints don't trigger every time. One of the things that is really useful is if you look at, let's say, expressions. So this window over here only shows you the local variables that you have. But you can add a window, a view to this thing that is called, so let's go to Azure here. In the debugger section, I want to add an expressions view. So if I click OK, it's going to add this expressions to the currently active panel. So I added something here yesterday. Let me delete this real quick. So when you start this, this is how it looks. Let me add an expression. So let's say, for example, I would like to print cycle plus 17, just as an example. So you can enter any expression here, and it's going to show you whenever it stops here. Or actually, so this expressions window is not active just for breakpoints, but wherever you are, it's going to show you what the value of this expression cycle plus 17 is. You can also have expressions here that call other functions. So one of the things that you could do, for example, is I could have an expression of the kind dofhandler.in dofs. That's something that I didn't try at home, so it may or may not work now. But let me try this out. OK, so indeed, I can call this function, and it's going to return to me 4425. If I call continue, now it stopped again in the next cycle. You see that the ndofs has changed now. Okay, so you can enter all sorts of expressions in these places here that that help you figure out what it actually is that's going on. What I don't have a particularly good example for, one of the things that you can do in these places is you could, for example, also call functions like output results. Output results, of course, is an expression that doesn't return any particular value. It has a side effect. So ndofs is essentially just a function that queries some sort of information, but it doesn't have a side effect. If you call it 5 times, it will produce the same result 5 times. Whereas if you call output results, it's going to create 5 files for you. Well, they might have the same name, but it actually does something to the state of your program or to the state of your operating system, your file system. You can enter these there as well. So the type in that case would be void, and the value would be non-existent. But these sort of things are oftentimes very helpful if you want to debug things. Let me see, I had a list of things that I wanted to demonstrate. So I showed you evaluating expression, breakpoints. I showed breakpoints with conditions. I showed you how to step in and out of functions, and I showed you assertions. I think I showed everything that I wanted to show in this thing. The one thing that I really would want to emphasize is that if you learn how to use a debugger, it is an enormously valuable tool to find out what is really going on in your program, because you can look at variables, you can look at the state of a program, you can evaluate expressions, you can also change things. Maybe that's what I should show here. So let's say cycle in this case here, what did we learn? Variables, so the cycle was equal to 6. I can add an expression here of the kind cycle equals 2, for example. Okay, that assigns a new value to cycle. Okay, so if I look at the variables now, cycle is still 6. That seems wrong to me. Let me step over 1. Okay, so it just didn't update it, but after doing one step, it actually realizes that cycle equals 2. this is an expression that I probably want to get rid of again very quickly, because otherwise it would be evaluated after every instruction that we execute. So you get to see the power of a debugger here. And what I really want to encourage you is to get familiar with this. Get used to the abilities of a debugger and learn how to use it to find bugs. It's a much more powerful tool than to use printf, because, for example, you can change the values of variables. Maybe that is what I can do here too. If I double click on this, I can, well, yes, if I single click on it, I can set it to 5, for example. So if you want to test your algorithm with a different value because you realize that you forgot an assignment, you can change the value, you can let the program continue to run, and so on and so forth. So get used to debuggers. It's a useful tool. All right, this much for this lecture, and then in the next few lectures we'll come back to things that have nothing to do with debugging, but more with, let's say, an outlook on computational science, in particular on time-dependent problems.